Hello, welcome to another trigonometry video. So in this video, I'm going to talk about coordinate plane and the angles on the coordinate plane and their sign and their values. Okay, let's start. So when I'm saying angle, we will think like we have an angle theta. This is initial side. This is terminal side, and this is the vertex. So this theta is going counterclockwise. And we always put the initial side on the x-axis. What I mean by x-axis? Okay, let's make an xy coordinate here. This is my xy coordinate. And okay, so let's say we have an angle. Choose different color. Let's say we have this angle here, theta. So this is moving counterclockwise. Counterclockwise. So it's moving counterclockwise. We said it is positive angle. Let's say we have another angle which has same terminal initial side but different terminal side. It's moving from here. Let's give this one another name. This one alpha. So since it is moving clockwise, we said this angle is negative angle. Okay, so continue talking about coordinate plane. So when I'm talking coordinate plane, this is my first quadrant, which means our theta or alpha, whatever we are calling the angle, is between 90 degree and 0 degree. And this is my second quadrant. And this is between 90 degree and 180 degree. This is my third quadrant, which is between 180 and 270 degree. And last one, fourth quadrant, between 270 and 360 degree. We should keep those in mind. So when I am saying coordinate plane, these are x-axis and this is y-axis. And we know x and y-axis. In first quadrant, x is positive and y is positive. Here, x is negative and y is positive. Here, both of them negative. Right? How we know? We know, right? -1, -2, -1, -2. So this quadrant, both of them negative. But here in the fourth quadrant, x is positive, y is negative, right? Y's are negative and x is positive. Keep this information in our mind. Let's continue talk about angles. So angles are in same place on the coordinate plane, we said coterminal angles, which means actually they are same angle. What I'm meaning this, for example, I have 60 degree. So can I say 420 degree equals 60 degree? Let's think about coordinate plane again. So 60 degree, something like that. Okay. So if I have full circle from starts here to here, so this is 360 degree, right? So when I start from here, from 60 degree, and make a full circle around it, I am coming same place, right? So 60 degree plus 360 equals 420. If I am coming same place when I make full circle, so these degrees are equal. So we can make it like 420 plus 360, 780 degree, which is equal. I can write it right there. Okay. If I continue adding 360 degree, I will get similar angles with 60 degree. Okay. Okay, let's say we have given a very big angle. Let's make another example. Example here. Let's say we have given 840. How can I find a small angle equal to 840 degree? It's easy. I will just minus 360 degree from that. So I will get 480 degree. If I take out 360 degree again, I will get 120. So I think this is small enough to put on the coordinate plane. Right here. Why we are doing this? Because 840 degrees is too big to showing on coordinate plane. I cannot imagine where it is. But if I simplify it and then make it smaller angle to I understand, so I can show it on the coordinate plane. Like we know 120 degree where is on the coordinate plane. Okay, let's say we have negative angle. Okay, but we want to express it in a positive angle. Let's say we have negative 30 degree. How can I express it in positive angle? So negative 30 is like that. Okay, so I should show it with this green part. How can I say green part? So if I take out 30 degree from 360 degree, I will get this green part, right? This is 330 degree. So which is, we know actually how much in coordinate plane. So we know some values like sine and cosine in the unit circle. So this is why we are doing this kind of things. Okay. Let's now talk about some sine. Oh, again. Sine of trigonometric function. Okay, I said we know here positive, positive, here positive, negative, here negative, negative, here positive, negative in the 4 quadrant. So let's make a table for the sine and cosecant, cosine, secant, tangent, and cotangent table and their sign on the coordinate plane. So this is quadrant 1, this is quadrant 2, quadrant 3, quadrant 4. So we learned from the unit circle in the first quadrant, we know sine is positive, right? Remember, these are sine, these are cosine. Okay, the first quadrant, if sine is positive and cosecant also same sign with sine. How about second quadrant? In second quadrant, our sign is again positive. Third quadrant, we have negative. And fourth quadrant, we have negative. How about cosine? We know cosine is the first one. So in first quadrant is positive. In second quadrant is negative. Third quadrant is negative. And fourth quadrant is positive. Okay, it's easy from the unit circle or in the coordinate plane. How about tangent? So remember, tangent is sine over cosine, right? So from here, if I divide positive number by positive number, I will get positive, right? Or here, if I divide them each other, I will get negative number. If I divide this each other, I will get positive number. And if I divide these each other, I will get negative numbers. Okay. So you don't have to remember this table. Only you have to remember the trigonometric unit circle and their sign from the x and y axis, like x and y. Once you know sign of the x and sign of the y in the quadrants, you will understand the sign of the sine and cosine. And then when you get the cosine and sine, you can find the tangent. And once you know sine, cosine, and tangent, you will know cosecant, secant, and tangent. Okay, one more term. Cofunction relationship. Cofunction relationship. So if we know sine of theta, we will know cosine of 9 minus theta. These are equal. Let's say if you know secant of theta, we will know cosecant of 9 minus theta. If we know tangent theta, we will know cotangent 909 minus theta. So like sine, cosine, secant, cosecant, tangent, cotangent. So co means like they are same. Same, yeah. 90x minus theta equals the other ones theta. What I am meaning, let's give an example. Like say sine 40 equals cosine 90 minus 40, which is cosine 50. Yeah, we can write all of them like that. Actually, let me remind you from the unit circle. Unit circle, we have, for example, here 30 degree. We have 60 degree here. Remember their sine and cosine values were opposite each other. Like the cosine of 30 degree was equal to sine of 60 degree. And the sine of 30 degree was equal to cosine of 60 degree. Like that. I think that's it for today. Thank you.